So we're entering the final run of this amazing conference, and we hope you really liked it. My name is Soufiane Karad. I'm a quantum performance scientist at Pascal, and I have the pleasure of introducing this panel, which is titled Seizing the Moment, Accelerating Dual-Use Quantum Technology, which is organized by the National Research Council of Canada. So the usual reminders, you have the CSPC 2025 app available, which we encourage you to use, especially to fill out the survey form at the end of the panel. This will help us keep improving from conference to conference. We also encourage you to share your favorite moments of the events via any social network that you like using the hashtag CSPC 2025. And yeah, that's about most of it. We hope you're going to enjoy the panel, and I'm leaving the floor to Gilles Lefebvre.
Okay. Merci. Merci beaucoup. Bonjour à tous et à tous, toutes, je veux dire. Welcome, everyone. Very nice to be here this afternoon. Thank you for attending the session. My name is Julie Lefebvre. I'm the Vice President of Emerging Technologies at the National Research Council. We have, within the National Research Council, a growing expertise and a large focus on the development of quantum and science technologies, all in development and in partnership with all of you and many of you here that are here in the room. And so I'm really looking forward to the discussions today, which is focused on ways in which we can strengthen and accelerate the growth of the Canadian quantum sector. And so we have three expert panelists who are here with us today, and I'm going to introduce them in just a moment. But we're going to look to see how Canada can continue to be a leader in emerging science and technology in quantum, and especially on how to advance the dual-use quantum science and technology that have both the civilian and the military applications. I will be conducting a lot of this dialogue in English, but of course, I'm very happy to entertain questions or any comments in French, en français, n'importe quel temps. On est pas mal équipés ici dans notre groupe. Donc, this is a very timely discussion. Budget 2025 has just been announced, and in that announcement, the Defense Industrial Strategy, it mentions the emphasis on AI, quantum, and cyber technologies. And with that, and I'm going to read the one which is specific to quantum science and technologies, and it says that there will be $334.3 million over 5 years for a suite of measures to help, and I'm going to pause on some of these words, anchor quantum technology companies in Canada, and provide pathways for technology adoption. So anchoring, adoption, and defense-related application in industries. And I think this is a very short sentence, but it's loaded in terms of the mission and what we need to do in order to ensure that Canada continues to stay at the forefront of the development of science and technology. And so you hear, like this morning, I attended the session on quantum science and technology, and they talked a lot about this ecosystem approach, one whereby as we work on the development of these technologies, we look at all of the supporting technologies and ways in which we can ensure that there's a future for these companies as they grow. And there was also some mention also on adoption. And I'll be looking forward to hearing from our panelists, and in fact, and through questions through all of you, on some of the insights in that area. So, donc, je ne veux pas retarder plus. Je vais tout de suite embarquer avec la discussion avec nos experts. So this is an opportunity for us to continue a dialogue we started with the National Quantum Strategy. In fact, we started way before that, but was precipitated by the National Quantum Strategy. And what I hope for today is that this and many other events coming up into the near future that we keep this conversation going. So with that in mind, I'd like to introduce our panelists. We have here with me, or up here, Nipun Vats. He's the Assistant Deputy Minister of Science and Research Sector at ISAD. And Nipun has held a variety of positions within the federal government, including in PCO and the Department of Finance. He heads up the National Quantum Secretariat at ISAD, which leads the change on implementation of Canada's National Quantum Strategy. So thank you for joining us, Nipun. Alex Mayaren is the co-founder and CEO of Phantom Photonics. Alex holds a master's in mathematics, specializing in quantum information from the University of Waterloo, where she is currently pursuing a PhD. Her research at the Institute of Quantum Computing led to the founding of Phantom Photonics, Inc. And the company emerged from breakthrough developments in quantum LiDAR technology achieved during her graduate student. So thank you for joining us, Alex. And then finally, we have Christian Sarah-Bournet, is the Quantum Strategy Director and Executive Director of l'Institut Quantique at l'Université de Sherbrooke. Christian has made significant contributions to the development of quantum S&T research and training, and notably with the establishment of the first IBM Q Hub in Canada and the creation of Quantum Innovation Hub in the Sherbrooke area. And so with that, I'd like to thank you all for joining us. And so I'm not going to hesitate, and I'm going to jump right into the questions. And, you know, we all know each other. In fact, I know many of you out here in the audience. So please, it's nice to see that we've come together to continue this dialogue. Oops, sorry. So I'm going to start with a question. I'm going to start with a question for Nipun. Nipun, what does seizing the moment mean in the context of quantum technology today? And then, you know, how can we best support the quantum ecosystem? Okay.
Press the button. Can you hear me? Yeah. So to answer that question, I think there are a few different dimensions to where we are in a point in time now. So from a technological perspective, you're seeing a lot of these technologies that have been thought about or dreamt of over decades, literally. When I was, a graduate student in the 90s, started reading about quantum computing and dabbling with stuff that we thought was, some people said was 5 years away, but we thought was a sort of a pipe dream. Well, we're hitting that point in terms of the realization of these technologies, similar on sensing, on communications, and as that comes together, it is a point in time where that sort of next generation of quantum information-enabled technologies are real, starting to be applied. So there's that component of it. Coupled with that is the fact that as they become more real, both industry and governments need to better either apply or know how to handle these technologies. So there's a security and defense dimension, which is why they were always inherently dual-use technologies, and so now the defense and security uses are actually things that governments need to take very seriously from an applications perspective, but also from a threat perspective. And in the context of our geopolitical situation, it means that we need to be thinking about our own sovereign capabilities and how we work with our allies to make sure that we are able to secure our collective interests. Because those technologies are right in front of us, it's a really important moment to be both thinking about what we need in Canada, but also how we work with our partners to make sure that we can support our own security and prosperity. And then along with that is the fact that in Canada in particular, we have a pretty robust ecosystem, right? We have, we've always been known for our talent and our research. But we're also one of the world leaders in terms of startups, and we have one of our founders next to us. But when you look internationally, I think we're second in the world in terms of the number of startups that Canada's created. So we actually have the foundational pieces you need to actually pull those together, both for our security needs, but also for our prosperity. And so we'll talk about adoption a bit later. That's kind of the other piece of that you need to make that happen. But seizing the moment means trying to catalyze those pieces, right? It means trying to think about how we can actually support the development of those technologies and capture the applications, the revenues, but also the security and sovereignty dimensions of that in our own interest, working with our international partners to make sure that we are collectively accelerating the development of these technologies and that we have access for our technologies into markets internationally, and continuing to support that ecosystem that's actually kind of critical to making all of this go, whether it's on the research side, the talent side, and also those supply chains that you need to actually build these technologies. So it's a combination of those pieces, and it's not easy, but seizing the moment requires that you kind of deal with all of those at the same time.
Yeah, you've introduced really well the complexity of what that statement can mean. And in fact, it's heavily populated by a startup industry, and we know that there are challenges, at all levels of industry. And so I guess what I would like to ask is, Alex, what are the types of challenges are you facing, or do you perceive that quantum industry is facing today, and how can we better address those challenges in this moment that we want to seize?
Thank you, Julie. I think from where we're sitting right now, which is at a fairly early stage, and I think a lot of startups are at a relatively early stage, there's a lot of funding in Canada actually for early stage development, but then there's a gap from very early technology to product. There needs to be a little bit of investment, or maybe a lot of investment, rather, to take an innovation and build it into a product. So I think that would probably require collaboration between venture capital and government. And with quantum tech, there is an element that is also deep tech. It takes longer. It's more expensive to develop, which is not a level of risk tolerance that is standard among Canadian venture capital. So what I've found is that in attempting to fund this gap and requiring more funding than is standard for a startup at this stage, VCs will tell me that I'm raising too much, and I've heard this from other founders as well. So perhaps we need to shift our perspective on what it means to actually be able to take tech to market, specifically when we're talking about quantum.
That's a very good point. Thank you for that. And Christian, from a university perspective, moving into and navigating the dual use of technology development, I'd be interested to hearing, your thoughts and what are some of the challenges or opportunities in this context.
Also, hopefully this works. This works? Yes, okay, good. Bonjour tout le monde. Thank you for the question. I'll touch upon what Alex has just said as well. I think in terms of from a Canadian perspective and also the market that's available as well in Canada, I think it's too small for a company to think that they're just going to sell to Canada, so they need to go international. But the government or the state, in a way, needs to be kind of like an entrepreneurial spirit and maybe being that first buyer. I think the last budget is a good sign in the right direction. But when you look at different programs in terms of science policy, the ISC program, for example, there was a few calls that were there for quantum technologies, but the amount of time it took, so I'm giving you clear examples, the amount of time it took to get an ISC call for proposal to get to a contract, one company that we have in the Quantum Innovation Zone was so far ahead that they were no longer interested in taking that contract from an ISC. And when you look at the counterparts in the US from the ISC, which would be the SBIR program, when you compare the number of call for proposals that we see coming out of ISC, it was about 100, 120. I think last year was about 19. Just in 2023 in the US was 2,000, 3,000 call for proposal. And when even if you divide by GDP or even if you divide by population, it's not at the same scale. So I think in terms of science policies, there's a few different programs that we can use to kind of, as a government or as a state, kind of being de-risking those technologies for those startups that we have in Canada. It's kind of like being that first buyer. It professionalizes as well the company and what it actually means, but it actually needs to move faster, because as the ISC example that I just gave, just took way too long. So more agility, I think, at a faster pace is what's needed for those companies as well to grow and actually to start professionalize themselves as well, and then getting revenues, and so that then they can go to the market and try to sell in other countries. But to your specific question, I think this is a very interesting question, I think, because the dual use, I think, is the buzzword of 2025, as Lisa Lambert said a little bit more this morning as well. From a university perspective, especially in quantum, I mean, most of you have probably seen the Oppenheimer movie. Like, there's not an epiphany this year that what we're actually doing is dual use. Like, quantum is dual use forever. Like, nothing will actually change this. So as a university perspective, navigating in a world of dual use means changing absolutely nothing of what we're actually doing. There's no quantum researchers, especially in Canada, that I think never, like, always understood that what they were doing was dual use. And if one of them actually says that, no, I'm not doing dual use technology, or the research I'm doing is dual use, they're in a state of complete denial. Like, I honestly think that from our perspective, I don't have to shift. What has shifted is the rest of society. And now I need to navigate in this world. Okay, what does it mean now to basically do research in a way that maybe some of the funding that I'm actually I'm gonna get through defense? And it's something that I would say most of the quantum research community is eager to get involved. Like, they know that they want to get involved, but they're kind of in a wait and see approach of what it actually means for their research. So all of the universities have already guardrails, like firewalls, ways to think about how their research could actually have dual use. Like, this is already in place. Do we need to brush it off a little bit and, like, kind of look at the responsible innovation parts of it and making sure that in terms of ethical direction, there's might be some updates that needs to be done, but this is already in place in the university. So I would say that we haven't changed, like, and we're eager to seize that moment and being more involved. That said, what's changed though is the security research. Like, as a matter of fact, in the University of Sherbrooke, like, we are, in terms of quantum research, one of the most active universities that are trying to get in terms of quantum research that we've been doing. And quantum has been a very, very open and collaborative spirit, especially internationally. So if something has changed, though, is that I need to act on the security research of how we actually approach our international collaboration, our collaboration, because now it's a matter of technological sovereignty and making sure that we keep that IP. There's no spying of it. So there's might be something that's changed through this, but for the rest, I would say most of the research community that wants to get involved are really eager for that challenge. There might be some education at what it means now to publish results, to publish the scientific output that they have. Do they need to patent it? Is there some things that they might leave under the hood in terms of use cases that could be classified? There's a lot of education, I think, that needs to be done through that. However, there's one blind spot that I think we're starting to see. A year ago, you would have, if the president of the university would have told me, okay, we're going to do dual use and got to get defense spending. Please build a communication strategy so that the university has kind of a social acceptance through this that we're going to do. A year ago, I would be kind of scratching my head. It's like, how I'm going to approach this. In 1 year, everything changed. Everybody seems, oh yeah, okay, all right, let's go. Like, we're on. Like, we're eager to do it. But I'm on the belief that, and we're starting to see it locally, especially, let's say, from the humanities and social science aspect of it, that pivot that really happened in a day that makes my life easier. But we're starting to see that there's a discussion at the university level as well to kind of, okay, what does it actually mean from university level? Are we eager to work in total, accept all that defense spending? Where are the limits and so on? And I expect that we've some blind spots as well in the population as well as to, okay, we've all with open arms, we've opened those new possibilities, but I think there's a discussion that needs to be had in the universities, in the research community, as well with the population, because I think we each one of us here have a different definition of what it means to dual use. So that's first. So it's very important that we have this dialogue. And again, from the first National Quantum Strategy, and again this time, I would argue or vouch for a little bit more of funding in terms of humanities and social science, and that they get involved in what we have in plan, especially in terms of defense research. And I know they're also eager to get involved in that interdisciplinary research and making sure that we don't forget about humanities and social science.
That's excellent. Alex, did you want to add?
If I could just add one thing, going back to the very first point you made about Innovative Solutions Canada and moving faster. To give you guys some numbers, Phantom Photonics is 2.5 years old. Waiting for funding for 6 months is a very long time for us. So I just wanted to make that point. But also I wanted to add, you were talking about the academic perspective and bringing in defense funding. As a student, some discussions that I've had with my peers about defense funding is that students are concerned that projects that they get may not end up being publishable. And if you're a graduate student, your ability to graduate rests on the fact that you're able to publish some stuff. And so there's this kind of hesitance. And I don't know if there's a clear answer for how to get around that, but there it is.
So, and I wouldn't even go further than that. So it's very interesting to see the next generation of students coming in the Research Institute. They really want to have impact. And social impact. So this is now key. So I would say 20 years ago, I would say, here's a hard problem, love it, and work on it for 4 or 5 years. Now I need to say, here's a hard problem. Why are we actually attacking that problem? It's because of this, and now it's going to change, especially for carbon capture or battery design and so on. So they're really eager to, okay, how my project will actually have societal impact. It's the same project, same fundamental research, but they need to see this. Seeing that defense angle coming in, they have a lot of questions. They do allow a lot of questions about, okay, I'm interested, but I want to make sure that the impact that I'm going to have is going to be positive. And this is something I think that we've done well in Canada, that I see a little bit less, let's say, in the US. And even I was in Copenhagen last week, kind of a little bit dystopian kind of approach towards quantum technology, which kind of put fear into them. So it's okay, of course, there's a very big threat, and that's why we're here, making sure that all infrastructure as well in terms of defense, we're safe. But at the same time, there's a positive messaging in sort of the dual use. There's dual use, and there's the civil use. I think messaging is very important that we keep in mind that what we're developing in some of the quantum technologies, there's of course a defense application, and those will be first. But as a country and as a research institute, especially if I want to bring the best students out there, they want to know what's our posture towards this. And I think keep that positive messaging in terms as well of the civil use of the quantum technology is very important.
I can see that. So as we pivot, for lack of a better word maybe at this time, and support our national objectives in defense, for defense, and bring quantum technologies to defense production, what you're saying is that there's a dialogue within the academic community that has to occur, in moving in that space. And I appreciate your point. It's a really important one. And in that vein, of course, Nipun, going back to you, it really is about then in that case, from an industry perspective, how do we ensure, in fact, also academic, that IP products and benefits are then retained in Canada?
I'm going to tackle that from a couple of different perspectives, maybe starting with something that Alex said about risk and the role of government. I mean, the way that we have typically thought about industry support programs has been about what are the benefits to Canada, typically from an economic perspective, a jobs perspective, which and what is the kind of market failure that you're trying to address in that context. And I think it's important to still underpin your thinking on those things, but you have to add an additional layer in this context, which is about what is the value to society of retaining a sovereign capability, right? Of course, anchoring a company in Canada, whether it's actually, of strategic importance or not, and having that economic return flow primarily to the country is always going to be important. But the way that you kind of account for risk is probably needs to be discounted when you kind of factor in the strategic importance of having these capabilities in your country. And so that's the part that I think the system needs to kind of respond to a bit more thoughtfully in terms of how we decide how we're going to actually make these decisions. I think on just a little bit of inside baseball, but on the ISED side of the equation, I think we take kind of a more hard-headed analytical approach from the economic benefits side. I would say that from the defense side, because it is in many cases a relatively new area for them, there might even be a bit of irrational exuberance, like in terms of how they're thinking about the strategic capabilities. And if we're going to do it properly, you have to bring those two sides together and sort of say, okay, we've done our analysis, our diligence, we understand what this company does, and we see the strategic importance of having this, and so we're gonna actually sort of look at how we invest differently, and that's something that I think you've been running a bit against. So we have to tackle that quickly because others are seeing this and others are making decisions on this more informed basis. So we don't have a lot of time to waste on that. In terms of the nature of investments that will actually kind of anchor companies to Canada, I mean, it's an interesting one because, you can't, if you tell a company we'll give you money if you stay, it doesn't help them raise money, right? Like you can't just sort of, sort of handcuff a company from making business decisions. But what you can do is you can think about the kinds of investments that anchor their activities in Canada and give them less cause to actually look for capital elsewhere, right? So an example of that is, if a company needs to build a facility, if you have infrastructure here that actually is unique and beneficial to what you need to do, then, you're investing in that infrastructure, potentially for the benefit of that company, but also potentially for the benefit of a broader ecosystem of companies in Canada. So investments like that actually can have an additional effect of mitigating your risk, because when you build something that's of relevance to one company, even if that company doesn't succeed, it's actually an asset that can be of benefit to the broader ecosystem, right? So that's one kind of example. There are cases where equity investments probably make a lot of sense as well. And to my earlier point, you need to have a bit of a different calculus on how you think about equity in companies to help support their growth and retain greater ownership in Canada and not force them to dilute their cap sheet too quickly. And then you also have to think about it in the context of that broader ecosystem. You mentioned, Julie, this morning that, that was a part of the discussion, but you have to think about the company and how they plug in upstream and downstream in terms of their supply chains. Like, do they have what they need to actually grow, which is often not something that the company itself can control, or do they actually have a path to a buyer, whether it's government buyer, whether it's if we go again to adoption, can we actually help to incentivize or at least expose Canadian firms who could actually benefit from being early adopters of these technologies to the producers of those technologies, and by so doing accelerate that development cycle into a viable product that actually has benefits further beyond. Because those kinds of things that actually help companies stay majority Canadian owned, build out the ecosystem, and have that revenue stream makes it such that there's no reason for them to go anywhere else, right? There's generally a desire to stay where you started, and we need to try and help support that. So
that makes a lot of sense. Christian, did you want to add to that?
I would just like to second what Nipun has just said about the facilities or the infrastructure that's been built in Canada. I think in the last 30 years, I think the CFI program is one program that's looked upon internationally as like being a very successful program. And in fact, I can vouch that most of the quantum startups that we've got in Sherbrooke or in the Quebec area, and some of them that we actually attracted internationally, came for the research facilities and the capacity that we have. And in a policy kind of spirit, you got to understand that building a quantum technologies requires a lot of enabling tech that's all around. So it could be photonics as well, the microelectronics approach, any investment in advanced manufacturing. Even let's say that quantum is not the economic growth that we're expecting out of this, is still worth the investment in terms of all the other industries that actually are benefiting from this. So I would second what Nipun has said. It's like we're attracting companies and they're staying here because of the research capacity as well as the manufacturing capacity that's been built through time. And I would say that it's the bad expression to say, but I would say some countries would sell their soul to have what we have right now. And in thinking about seizing the moment, we're not a small player in quantum, both in research, and we should have a posture internationally in how great we are, also in the capacity to actually build and manufacture those technologies just right here.
Absolutely. And Alex, you're navigating this space right now, as I can imagine, with supply chains and looking for ways to manufacture and anchor a company like yourself, like yours, here in Canada. I wasn't sure, do you have a perspective that you can bring to us so that we better understand the challenges and what you're working through?
So as it pertains to supply chain, being a dual-use provider, we have to be cognizant of what limitations the defense side of the sales will bring. And we can't be buying electronic components from China, for example. It's just not going to fly. But then we just happen to also be deploying our tech in very harsh environments. And so we also want top-of-the-line non-electronic hardware as well. And so that also precludes cheaper components. So we source our supply chain from NATO allies, as well as Japan, South Korea, that kind of thing, and the US as well. But with the US having imposed some tariffs recently, we had major delays in components coming in that we needed to build prototypes. So company would send their stuff to the UK first, and then it would come to Canada. That was like a multiple month delay for some reason. So there are some challenges in terms of supply chain. There's a little bit of a limitation in terms of where we can get stuff manufactured. But I feel like within the NATO alliance, there is enough capacity that it's not prohibitive.
Thank you for that perspective. Okay, I'm going to go to Christian, and I'm going to go back to your points with respect to the academic community and the workforce. So what strategies are the most effective for growing a quantum-capable workforce? And what are the barriers that you see at this point?
Okay, I think the easiest or the shortest answer is usually what we would say is like we would ask Nippon for more money for scholarships. But actually, that's the wrong answer. Let's not fix what's not broken. In terms of the system that we've got in Canada, in terms of the training of PhDs and postdocs, I think we're in a fine place, and that's coming from a research institution. So. What we see, though, is that, when I travel the world, most of the countries went to this idea of more PhD and postdoc scholarships, which I think is the wrong approach to it, because the number of people that you're actually pumping out of our research institutes is not enough for what the industry is actually what they want and what they tell us that what they want. They're at a stage of growth. Most of them would say, okay, we're training the best, that's for sure. We are the best here in Canada. The talent is there in terms of quantum, but what I require are engineers, or more kind of undergrad, or I need computer scientists. If I'm gonna build that software, I don't need someone that actually are a quantum scientist per se, but I'm at the stage where I need to have a graphical user interface, so I need to interface with AI, and then I need engineers, technicians as well to maintain the equipment or kind of salesperson, marketing, exec. So what the industry is asking us is the competency framework that they need is way different than it might be in the past. How many PhDs and postdocs in quantum you actually require in your company compared to the growth of what you actually are looking forward. So I think the best strategy or more sufficient is that as ecosystems, you work your college and the university and you figure out, okay, are the programs okay in terms of the training, but what they will actually lack usually is team building, entrepreneurial spirit, project management. Those are the kind of skill sets that those companies are actually looking for. There's other approaches as well. So this is kind of the classic university play. I would say that training in-house in enterprises is the way to go. Find those hidden physicists as well, and some of the companies are the best strategy if you want to get adoption of quantum technology. That those physicists are just looking forward to work in quantum computing, for example. So our most successful strategy has been finding those hidden physicists that are in managing positions in some of those companies. So I would say more professional training, I think, is the way to go. Not necessarily, again, to create quantum computing experts. It's just like that quantum awareness, so that they understand that what's coming in their field or their sector, how can, as a Canadian company, they can actually have an advantage over other international players, for example. If there's one other layer, I think that's really efficient that we need to think about now. And there was a very good program in the first NQS strategy inside the government. I think it was QRDI, if I'm correct, in terms of the quantum awareness program of training. And so all the different ministry, those that were interested in quantum, kind of managed to kind of build their own little effort and see where the use cases and where to and create that quantum awareness inside government. I think it's fantastic. But let's go one step further. We've got critical infrastructures as well. There's the banking system. There's a lot of different telecoms, for example. We got to go exec. And why? Because they have a responsibility as well of making sure that their industry is quantum safe. So that's the first thing that they need to do. So it's not only like training in terms of quantum. I think right now it's in terms of governance and responsibility of what it means as a country. I think the best outcome that we could get is that nothing happened in terms of quantum safe. Like if all our critical infrastructure is safe, making sure, but it goes beyond the government. I think we got to look as well at some specific industries that we want to make sure that they stay like they are and they can progress and grow. So I would go exec, professional training, and I would say that PhD and postdoc is fine. I think we're great at this, but there's other ways that we actually train more people. In Sherbrooke, we started a new undergrad degree in quantum information science. The idea is getting someone who, after a 4-year degree, that would be ready to enter the quantum industry. This is already 4 years as long, but a PhD or a postdoc is 8 to 11 years. So if we want to have a quantum industry here, we got to find new ways. So that means new curriculum and listen to what the industry is actually asking for. And it's not more PhD and postdoc at this stage now.
Could I add to that? I mean, one of the virtues of being in sort of quantum information and the quantum industry is it's emerging, but it's not pervasive yet. And if you look at the example of AI, we often talk about how we don't have those sort of big companies that we had all the intellectual heft and we don't have maybe with the exception of Cohere and a couple others, not companies that are of that scale that could have seized that opportunity. But there's also the other side of the coin, which is like we don't have great adoption of AI in Canada, right? Like it's sort of we maybe over rotate on the big company and not necessarily the productivity gains that could be pervasive across a range of industrial sectors. I think there's a little bit of a risk that we don't seize the opportunity of this being still relatively contained and small to kind of not make the same mistake when it comes to quantum technologies, right? Like, so it's hard with companies because it's got to be really real in the next quarter before they generally worry about it. But there are, these are risks for companies. There are opportunities from an economic perspective. And so if we can find ways to actually build those bridges to industries that are really going to stand to benefit or need to kind of mitigate risks, I think it would actually position us much better as these technologies come on stream to benefit. And that is a bit of a way of also insulating yourself from the risks that you don't actually develop. I hope we do, but if we're not the ones who get there first with respect to a fault-tolerant quantum computer that has computational advantage or quantum advantage, then we'll still have really benefited from the effort. So. Again, I'm not entirely sure the best way to do that. When you talk, we've had some conversations with some some associations and things, but I think more effort on that side would actually be beneficial to the companies that are trying to develop products and services, but also make sure that we benefit from the quantum sort of revolution, if you will, however it happens. So.
Yeah, absolutely. And so if I could put in a plug for NRC, we continue to build our workforce. And so we are an employer of good quantum talent, including policy analysts in quantum technology. So I just wanted to put it out there that we are always also participating and, I would say lifting our sleeves and jumping into the opportunity to do our fair share. Okay, so Alex, I'd like to come back to you, if it's okay. What kind of challenges have you witnessed when it comes to managing your IP in Canada? And how do you think about this in the context of, of the current environment?
So coming out of the University of Waterloo, we were very lucky in that they have a free IP policy. So we had a strong start. We got some grants early on also to fund our patents. So that was great. I have noticed a tendency of certain investors internationally where they're trying to attract companies to their local ecosystems as well, to establish themselves there, to hire folks there, and also to bring the IP there. So there's been a little bit of pressure on that side as well. But generally speaking, I think Canada is very good about IP. There are sufficient grants available, both provincially and federally, to get this stuff done. And we were also put in touch with some good law firms through the university. So for anyone out there who's trying to put together a patent or is thinking about it, talk to the IP transfer, tech transfer office at your institution. They might have some good tips and tricks, but there is something to be said about retaining the IP that we develop here to stay here and not let someone else take over what was effectively, bred here, right? Our ecosystem produced the folks who can generate new ideas, who have the skill and the talent to think differently and produce IP. We don't want to just lose that because the next stage of opportunities isn't in Canada.
So can I ask, so what are some of the, so you've touched on it a bit, but again, I want to reemphasize what are the conditions that startups look for to stay in Canada then in that case? I mean, this is a really important point. In your case, you're getting some pressure to, for example, have your IP then locate outside of Canada. So I'm just interested, what are some of those elements and how can we help?
So there are a couple of elements that are really important, I think, to be able to build a business here. People, so specialized experts, but also, Christian, what you mentioned about project managers and business developers and all the folks who would engage with the quantum industry, but maybe wouldn't have thought that they would work with quantum in any related way. We still need those people. So human capital, funding, and facilities. And maybe customers, that would be nice too. But those are the major ones. And because we're talking about dual use today, I'm just gonna throw this out there because we've been having some challenges with this: secure facilities. We're very lucky to be in an incubator, but it is kind of a come and go, lots of traffic, everyone's holding the door for everyone, even though you need a card to get in. We need secure lab space, we need secure office space. And I think it's also important for people to know what the security requirements are so that you can start preparing yourself. Like I can go online and I can look up what the cybersecurity requirements generally are for working with Department of Defense. But what are the physical lab requirements for having a level 2 clearance or having a top secret clearance. Like those things are not readily available. So I don't even have a way of like preparing ahead of time and planning or, you know, doing some budgeting about it. I don't even know who to talk to. So thank you, Nathan.
Christian?
I fully agree. We're exactly in that situation and kind of moving in that security research space. Like we do understand, like we got enough info, I think, from GRC and so on how we're maybe compromised already and how we're gonna fix this. But it's kind of like a tug of war between freedom to do the research how the academia researchers wants to do it. So anything that I would add as a layer of security, there's a lot of education that needs to happen first with them to kind of make them understand why we are doing this. Every time that we try to put something in there, it's like you're bridling my freedom. That's always like, I think they overestimate their freedom in that sense. And same thing in terms of international collaboration. International collaboration means exchange of knowledge. Every time that they go out there, everything that they share, there's a lot of education now, so that we need guidelines onto like answer in the Alliance program put the national security kind of evaluation. Researchers like it was something. Okay, so I need to now to be an expert in national security. It's an overhead that you're putting on. Yes. Understand why and what's at stake. I think it's very important, but that takes some time in education. So, but for security of labs, same thing. Everything that we're trying to add something, basically why. So we need a bit of time and as well as guidance and guiding principles that's helping us as well to communicate well to the research community as well as to why we're doing this and what's at stake for us, especially for Canada.
Yeah, I would even say that, you know, when you're navigating that space, so I spent 20 years in defense, getting that intuition as to when should one be concerned about what it is that one is developing and at what point is security consideration coming into play is an experience and an art. And I think that a clear discussion on that would be really important, not just from the defense security perspective, but from an economic security perspective. So there's two angles, right, to your defense and security of your capabilities. And so the economic piece, I think, to some extent, can sometimes be even more difficult to judge because it requires a really good understanding of where things are going into the future and, you know, the market availability and possibilities and things. So that's a very good point. And I think we need to get better at that. Nipun?
Yeah, I was just going to say that we are fortunate in Canada to have had a very long dialogue with universities on research security issues. So we have a standing table where we have representatives from the university community, security community, ISED, the granting councils, talking about issues related to security. And more recently, defense is kind of joining that conversation, so we can start to get more of this guidance out on the physical security, and personnel security is already kind of captured in some of these things. But so I think it'll be more codified and clearer for people in the university environment. But you know, I think we can, working with defense, we'll be able to kind of do a better job with that. I did want to also just mention, you know, Christian was talking about the reticence of some in the academic sector to actually do these things, right? And I think you suggested earlier that that is changing, and I like that is definitely the sense that I'm getting, like from talking to people. It's not to this extent in Canada yet, but I was talking to the head of the German U-15 a few months ago, and they're rearming. Germany's like seriously rearming, right, for obvious reasons. And he said, you know, when I talk to researchers in Germany, they now look at this from the perspective of saying that my children could be in a war. And if they're going to go to war, I want to make sure they have the best equipment possible, right? So there's actually a different kind of perspective on like what geopolitics does in terms of the cultural acceptance of the importance of issues related to security and defense that is playing out in general. So I think, you know, you don't want to over-torque that, but I think it does create an opening to have that discussion. And with our research security guidelines, you know, again, anecdotally, there are people who want to do the right thing, kind of cast a blind eye towards some of the partnerships they were having that now gave them license to kind of say, you know what, like it's not worth it. It's not, that money's not worth it. I'm not really comfortable with the risks associated with it. So there's also just a broader cultural impact to having those discussions and putting those expectations out there that I think is really positive for economic security and also for national security.
Thanks on that one. Okay. Thank you very much for that, Nipun. And on that, maybe what I could do is just ask you, recent announcement in quantum in Canada, of course, will support the implementation of the National Quantum Strategy as we continue on that path. And so then maybe get your perspective on how you see that alignment moving forward.
Between
the recent announcements in the budget, and then the alignment with where we have set a course for the National Quantum Strategy.
Yeah, I mean, I would kind of describe the investment in the budget as doing two things. One is it's sort of, I think of it as National Quantum Strategy 1.1, if you will. Like it's sort of but it's a way of doing that is bringing the defense side more into the conversation, right? So it's kind of like an on-ramp for the defense industrial strategy to kind of, get on the highway with us on the path to try to develop some of these technologies. So I think there are some other things that are kind of more 2.0 like that will need to be kind of brought forward over the next while around that broader ecosystem, around sort of supporting some of these companies that are scaling quickly and need support, around some ways of strengthening those research collaborations in strategic areas, and around promoting adoption and figuring out how we can help refine that product and have those benefits go to Canadian adopters and Canadian developers of those technologies. So I think, I obviously can't tell you we have gobs of cash, for that next phase, but I think there's a recognition that this is a way of bringing defense into the discussion, and that will allow us to kind of play both sides of the dual use purpose in a more deliberate way in what comes next.
Go ahead.
So I won't repeat things that I already said to Nipun on the first National Quantum Strategy, but I will add another comment is that let's say that the National Quantum Strategy, the first one was, let's say, academia-driven is the way that we love it, and I'm guilty as charged of being part of that story for the first National Quantum Strategy. What has happened through the last few years that I was kind of skeptical about is that we moved way too fast from, let's say, okay, it's no longer academia, it's technology and commercialization and adoption. And okay, we need industry adoption of those quantum technology. That's kind of lacking the fact that the maturity of most of those technology, maybe not sensing, but the other ones require still a lot of work to get up in the TRL level. There's a gap in between, let's say, science-based strategy and academia-driven and commercialization and its industrialization. And what I see from the last budget and the approach, especially with defense now getting involved, is that we're taking a more serious approach about that gap that we actually require those capacity in terms to build and manufacture our own technology, our technological sovereignty, as well as making sure that we look outside as well as what we don't have as well, and making sure that we find like-minded allies. There's no one country that I think can do it all. So we kind of need to look as well in terms of international collaboration and how we're going to behave and interact. And things coming back from Nipun's comments about we don't know which quantum computing, let's say, architecture was going to win. We don't want to pick one and basically be stuck if, let's say, we pick the loser. But still, I think making sure that we've got this capacity here, both in terms of the talent and as well as kind of the manufacturing capacity is very important, and making those connections as well with like-minded allies to make sure that we've got access to those technologies. I don't think we'll be able to build all the quantum tech here. What's more important, building it here, or in some cases, making sure that we also have access to it? And in some cases, there's, I think, some competing technologies and quantum technologies are trying to do the same goal. Fine, I like competition. I like the fact that some of those technologies can achieve the same results. But in the end of the day, some of them will be in Canada. We got to understand where we're going to fit in that supply chain. We're going to make some specific choices, I think strategic choices. We cannot do it all. To work with our partners and make sure that we've got access to those technologies. I think that's what's most important. And the G7 or NATO or the Five Eyes are examples of places where we need to ensure that we've got access to those quantum technologies as well.
And on that point, as part of our G7 presidency, there was a leaders' commitment to create a fund and a dialogue around quantum technologies. So we're trying to actually make sure that we, our capabilities are for us, but also our table stakes to ensure that we're at the table to be able to, benefit from the collectivity. And we're trying to make sure that G7 countries are trying to stay connected on the development of these technologies. So.
Yeah, that's excellent. So having access means we have something to bring to the table. And in that, it means thinking strategically and making wise choices for Canada. And I think that this should be very much part of the dialogue moving forward as we continue to navigate and bring in our defense and security partners as part of the, more explicitly as part of the national strategy. So with that, I'm confident that Canada is going to be a winner in this field. There is no reason why we wouldn't be. And so what are the types of things that we need, high level, that we need to focus on to ensure that we don't fall behind of staying ahead?
Make choices. It's a broken record, but we kind of need, I think, to make choices. And what's coming through my mind as well, especially I think there's a CCA report as well in terms of innovation. Like what keeps me awake at night is like the diminution in terms of R&D spending, not necessarily as a country, or it's more about what's happening in the companies as well. Like there's a problem there that I don't know how to solve, but that keeps me awake at night. Is that culture that we need to change to make sure that we're the best, we've got the best talent, we need that tech transfer and making sure that it's here. I don't know what needs to happen for this, but I think quantum has all the right ingredients in terms of a deep tech to make this successful. And it should be seen as a blueprint as well in terms of any emerging new deep tech that's going to come. It's not the end. Like quantum is one, but then there will be another one, and then there will be another one. And you see the acceleration in the amount of time that we actually have to react as well, kind of in policy, in terms of regulation. It's like, please use quantum as the blueprint in terms of all the ingredients that's there that we can actually succeed at this time as a deep tech that actually the economic growth and the companies stays here. But this is not the end. See this as well as kind of like a blueprint of how we can be more agile, more quick in terms of regulation and as well as in terms of policy, because emerging new tech will be coming over and over and over, and repeating the same thing and expecting a different result is the definition of madness. So my hope is that this time we can actually make it.
So I will build on what you said. You were talking about the perspective of not falling behind with technology as it comes about. I would look at it also from the perspective of not falling behind with the companies that come about, because startups move very fast and the institutions that support the startups don't. And there's a disconnect. And we run the risk of actually losing the kind of commercialization efforts that we've worked so hard to enable here in Canada if we can't keep up. And so I think providing support in a very fast way, being able to adapt to the needs of companies, and bringing down barriers for hiring interns, the amount of paperwork that's involved in that, just all of those little bureaucratic nonsense things. Forgive me, they're not nonsense because they were put in place for a reason, but if they're going to disable us from moving forward, they're nonsense. So that's probably an important step to take.
Can I say something to this too?
Oh yeah, I think you should.
I mean, there are a lot of pieces to this, right? So I think, it would be a real shame if government, I'm going to say it, didn't get its act together on this, right? Like it's sort of like there's a lot of interest particularly in quantum technologies, but also in a number of other kind of technological capabilities, where we have a range of instruments and a range of players within our system. We have provincial governments who are also quite keen to make sure that they can support regional ecosystems. And if we don't do a good enough job of kind of articulating our objectives and how we're going to mobilize what we have together, there will be a lot of activity, but maybe not quite the outcomes that we want. Of course, government can't be the determining factor in that, but if we're not actually kind of aligning what we do in a way that actually is where we agree on what we're trying to do and understand the complementarity or gaps in our efforts, I think it would be a bit of a wasted moment. So that's something that is important within government. Part of that is the risk, the acceptance of risk, I think, that we need to understand for these technologies. So I think that's a really important part. I think the other part, it's not just government, and this is an age-old problem, but we need more investment. Like we need people who are actually domestic investment in these sort of deep tech areas needs to be a bit more developed, like to be able to carry these things through. I think, again, I mean, it is a bit far off, but I think making sure that governments and industry are ready for these technologies is going to pay dividends, irrespective of how this whole kind of thing plays out. So I think spending a bit more time on that side of things would also be important, and it has upstream benefits in terms of our companies, in terms of our talent, because there's more of a pull if you can create that as well. So those are the things I would start with anyway.
Just want to add that I think immigration policies is really hurtful right now. And speaking from a Canadian perspective, but also a Quebec perspective, terrible from a university side as well as a kind of quantum ecosystem. Some of those companies want to grow and double their size and the number of talent people that they want to hire. And right now, the signal that's sent basically across the world is like you're not welcome. So this right now, like timely, the most hurtful kind of policy that's really hurting the growth of the quantum industry is the immigration policies, both on the Canadian side, and I would add to that layer to Quebec on my perspective.
That's excellent. Thank you very much. At this point, a little early, but I would like to turn the tables and open up the opportunity for our guests here in the audience to ask questions. So I don't know how that's done with respect to, okay, there's a microphone right there in the middle of the room. I don't know if there's another one here as well. So, okay, so we have an opportunity here to ask questions. So let's just start with this one here. If you want to introduce yourself, and thanks for participating.
Sure, thank you. I'm Elise Humane. I'm the AVP of Innovation at Simon Fraser University in BC, and I was also on that CCA panel. So I share your concern about both business expenditures on R&D declining as well as our R&D spending declining. But my question is it's been an excellent discussion. I think the points that you've been hitting on about both the opportunities and the challenges are spot on. I've heard from you several things about different gaps that exist in pieces of funding, perhaps in education, right across the fundamental research through to innovation continuum. And my question is mainly directed towards Dr. Vatz. In terms of, could you give us a perspective from ISED of how the government is thinking about coordination mechanisms to really think about those portfolio of possibilities in dual use technologies, but really thinking about having the different programs and policies all the way from the research institutions through to innovation, coordinating. Maybe some of that's capstone, maybe some's beyond that. Would love to hear your thoughts.
Okay, well, I will say there's a lot of discussion right now about how to do that well. I mean, I don't think that anyone's we haven't completely sorted it out. It does require a layer of governance, but even before you get to governance, you need to get to a shared kind of conception of what you're doing. I can give you, this isn't, I mean, we're not here yet, but in terms of how I kind of visualize it, you know, if you think about the CAF, you know, the armed forces, there are some things that they know they could benefit from having in terms of next generation capabilities. There are also things that they don't know. And so there's an element of defining those capabilities that requires a dialogue with allies, with Canadian industry, with the academic sector. And then you would sort of conceive of the priority of these things, and then what our strengths are, and where we can build on existing strengths, or where something is so critical for us to have as a domestic capability that we need to build it, right? So it always kind of comes from that definition, I mean, at least from the defense side, of those kind of capabilities, and there has to be a strong way of having that dialogue. Once you kind of have identified what those capabilities are, they will be at various stages of development, right? There will be some that are really in the lab, where you don't know where they're going to go, and you need to kind of invest in that. There'll be others where they're more advanced in their TRL levels, where you kind of have to make sure that the programming that we have, in the first instance, actually is aware of the priority and what we're trying to achieve with these programs, right? And then you need a way to kind of align those programs so that there are sort of clean handoffs, like in terms of where does this go? So from the granting councils, like particularly if Capstone comes together, there would be a way to kind of, there'd be more fluidity between what's going on in the academic sector and the industrial side. So there's a way to kind of transition that more seamlessly. We've got Mitch here, so there are things like IRAP that would be critical in that world. And, so there are a range of programs. We may not have the perfect kind of complementarity across, and you would learn by doing what those gaps are. But then you'd be able to pull these technologies through with a goal in mind. Then when you get, because they're dual use, there will come a point in that development cycle where you need to actually support the defense build out of those technologies. And that is where it's really important that you have the secure spaces for industry, that like the secure incubators and those sorts of pieces. Defense scientists are involved, and that at the end of it, that for the company's benefit, that there's a commitment to prototype, to test, to procure, so that they kind of understand that they're not just sort of doing this in the abstract, right? That there's an end goal, and in parallel, and there would be fluidity, like complementarity to that. There will be civilian applications that would carry through with our program suite, right? So that would be how I'd see it, conceptually working. That would require, and this is ongoing, it's like a very solid mapping of how these programs do and don't complement one another, what kind of governance you need to make that happen, how you make sure that those conversations are happening between the ultimate, like on the defense side, that the buyer is at the table right from the beginning, and that the defense research establishment and really understands those technologies as they're moving through. So how you actually configure that, not entirely sure yet, but I think that is the kind of conversation that needs to happen.
Question on this side.
Right, so I understand why ISED is investing early in quantum, but what I don't understand, and talking about risks and not investing early, but I don't understand, or maybe you could talk more about ISED's calculation of the risk of the societal impacts and whether that plays in to your assessment of the technology. I am super glad that the term quantum safe was mentioned, because that is so important in this discussion. And I hope also that it's not just computer scientists talking about quantum safe, but you involve the broad range of researchers in talking about this.
Do you want to start, or?
There was an excellent panel yesterday, I think, about this threat. I think we're really fortunate the fact that the threat was identified about 30 years ago, about what a quantum computer could actually do and break the cryptographic code. It actually took 30 years that now we now have a date in the calendar and what we need to migrate to. It might not be the last threat that we were going to see. Like, we were really lucky to basically know the threat before the technology was actually mature enough. So I think in terms of a risk for our society, I think as I was saying a bit earlier, it's like the best outcome we can get is that basically all our different economy pillars are not affected by this threat. And it's kind of like a vaccine. Like, you want, like, nobody will actually see that it actually works, and that's the best outcome we can get. And before even we talk about economic growth or creating jobs and so on, it's like it is a real risk for a society, both in the critical infrastructure as well as for defense. But even from different economic sectors, I think the best outcome we can hope for is that actually there's nothing happening, and we need to act very fast. I think we're not fast enough. And it is very important that both in terms of the government push everybody, as well as different economic sector as well, the banking system, the telecoms and so on, so that we migrate as fast as we can in terms of the crypto agility system, which is not the last threat that we're going to see. There's no proof that there's not a whiz kit that will actually find a way to crack those new codes that we're proposing. So we need to make sure that we invest as much in terms of just making sure that our society is safe. But I'll leave it to you, Nipun.
Yeah, I mean, I think that's right. Like, there are some things that we're doing as a government already. Like, there's now a commitment to move to quantum safe across the federal government, and departments have to have plans in place, for post-quantum encryption. And start implementing those kinds of things. So I think there are some, it's not as though the sort of security risks that are associated with these technologies aren't kind of part of that. And you also want to support companies in Canada that are developing those solutions, both because of the economic potential, but also you don't necessarily want to be beholden to others for some of these critical systems that you need. There's also work going on in things like quantum communications, so we have secure options for that. But as you say, like, if you kind of take the more dystopian view you were talking about earlier, like, if this plays out where you have, you can break, Shor's algorithm is brought to life, our banking system would be compromised, right? So our transactions on the internet would no longer be secure, and so there's a public trust element that needs to kind of go with that. So in investing in these technologies, again, in a dual use context, it's not just about defense, it's about our sort of security posture as well. There is a lot we don't know about what these technologies can do either. So there's a big research component in terms of algorithms, in terms of realizations of applications of quantum information that you need to keep an eye on. And in some cases we're working with the NRC so that we have the technical capabilities government to understand these technologies and what their implications are. So there are a whole bunch of different ways that investing in these technologies also gives us knowledge that's important in terms of how we need to manage them. I think we have to be a little bit careful though about moving to regulation too quickly. Like, there's always a kind of a fine balance about, are you actually impeding important development of technologies unnecessarily? So that's something that has been discussed to some extent. I think I heard one person say, if you think about what quantum technologies will be able to do, they'll enable us to do things that we're already doing, but way better, right? In some cases, that's not true, but in most cases, it's that. So at what point does that way better actually imply a need for a different set of rules is something you'd kind of have to think about. So it is part of the discussion, and there is some investment on the social sciences and humanities side that's been put out there for this as well.
That's a very good point, Nipin. I mean, for all emerging technologies, there's a point where you have to look at, and hopefully really early in the stages of the development of technologies, what are the vulnerabilities that these technologies are bringing as well as that benefit, and how do we ensure that we are protected against those vulnerabilities? Think of the internet, right? That was ARPANET research development way back. And in fact, Canada was the first international partner to test the ARPANET with the US. Out here with some leadership from Shirley's Bay and with our team and DRDC team in Halifax. So that's just a fun facts. But the point being is that, and then to a large extent, that plays into the discussion of dual use, making sure that we can protect and defend against the potential vulnerabilities and that we are aware of them and that we are prepared for them. Anyways, I could go on forever, but I'm going to go to the next question out here on this side in the middle.
Okay, thank you. My name is Brad Wallace. I'm with Defense R&D Canada. It's less a question, but it does address at least part of the conversation about needing secure facilities. My organization, DRDC, is part of a new organization, or is partners in a new organization called Borealis. You don't need to remember that. It's great if you do, but don't worry about it. But what's important is that one of the things that they are doing is they are building what they call Defense Innovation Secure Hubs, DISH. And its whole purpose is to allow innovators to work in secure facilities on defense problems. The first one of these is actually announced today. I just happened to notice it. It's in the Maritimes. It works on maritime stuff. But the reason I'm saying this twofold. One is that one of the areas that they are investigating is creating a dish for quantum technologies. This is on a list of facilities that they are interested in doing. They had an RFI come out in September. It's closed, unfortunately, right now. But I just wanted to bring that to your attention in case you're not aware of it, that it may exist. But I also wanted to point out that the maritime dish, they are building or have built, I'm not sure exactly where they are in the process, a secure facility specifically to bring in innovators from outside of government. So the organization is called COVE, and if you're really interested in finding out what it takes to get a secure hub, a secure system for your research, for your offices, I would suggest perhaps reaching out to COVE in Halifax. So, and I see somebody wants to say something.
Yeah. I can add to that comment. So we're very familiar with the DISH program, and I would say all the Canadian quantum community is really familiar with the DISH program, and there's probably a lot of proposals that went to that RFI. So Canada's strand in quantum is coast to coast, which is fantastic. I'm not expecting one place in Canada. I think that would be that would require secure labs, and I would say the Canadian quantum community, again, my first comment is like that's seizing the moment, is that we're eager to get involved, but we're kind of wait and see and what it means, but it also what it means in terms of timeline. So the comments that we're getting from other organizations or other technology and getting involved with the RDC, or I would say with defense, is like the sluggish pace at which this would be actually becoming. The momentum in quantum is going so fast that like we're kind of in a wait and see mode and eager to get it more involved. But that also means probably culture change on the other side as well in terms of defense and like how quickly they can actually evolve and adapt. Also in terms of what's classified, what's unclassified, what we can do together. So I would say, like, I will speak from the Canadian quantum community, like, yep, like we're ready, like with open arms. Still with, I think, a discussion that this needs to be continued as well in terms of what it means as a country as well. And like, I would like to see more humanities and social science being involved in any discussions that goes through this.
Yeah,
If
go
I
ahead,
could
Alex.
just add, so my comment is going to go back to what I said about moving at the pace of startups. We've had 4 security incidents at the lab in the last month. What do I do today?
I wish I could give you an answer
How
to
many
that.
security incidents until Dish gets set up somewhere near Waterloo? Or do I have to move all of our 9 employees to Halifax?
Well, it's not going to be in Halifax, that much I can tell you. But it might be in Quebec, I don't know. So, but I don't have an answer for you. I wish I did. But like I say, perhaps talk to the folks at Cove. They might be able to give you some pointers.
Thank you very much.
Thanks, Brad. We have a question on this side.
Yeah, thanks so much to the panelists for the really inspiring panel, and congrats specifically, Alex, on your startup. It's really inspiring to see what you're working on. I have a question to you, Christian. We already had the opportunity to chat the other day. I'm a social scientist doing research on science and technology, and I'm really happy to see that you want to involve more humanities and social science scholars. And what I like to do in my own research is to co-produce research. So I really like to go to the people that I want to work with or do research on to understand what are your needs, what would you be interested in terms of like looking at technology, quantum from a social science perspective. So what would help you?
So I'll answer this, and I don't know if I'm going to go on a tangent, but hopefully I'll answer the question at the same time. So in Sherbrooke, because of the Quantum Innovation Zone, we started a project that was actually funded by the FRQ and kind of what we call social dialogue. Since it's an economic development project, as a research institute, kind of like ivory tower, it's like, okay, we're going to need to be more involved with all the stakeholders to get an understanding of what are their fears, what they think about quantum technologies. There's an education piece, but as well, we wanted to be educated as well as how we communicate about the technology. And just kind of, it's a research project, and it's been really insightful to get involved with the folks in terms of the humanities to understand how we go through this process of getting more stakeholders in terms of a governance approach in terms of economic development. Results from the project, and it's not ended well, but I think that it's a kind of key insight as to what we need. It was interesting to see that, let's say, the academia researchers or those that are developing the research, their opinion at first was kind of like, it's more scientific, like it's curiosity-driven research. It's not my responsibility what will come out of my lab, which is kind of surprising. And then you ask the innovators, so those that are in the startup, to say, yeah, I understand what you're saying, dual use and responsible innovation. Ask me when I have a product because I need to keep my focus on, which is also kind of surprising. And when you ask the students and the grassroots and the population as well, some of them say, like, I don't see my responsibility in terms of science or public policy, which is also surprising. And the student says, you know what, like I would like to be more involved in that discussion, but there's no place in my curriculum in grad studies. But if there were, I would be more interested. But getting all those people together changes the mindset of both the researchers. It's kind of after a while, you know what, like I might have a responsibility of what I'm actually doing. Like I cannot hide myself behind this is curiosity driven. I'll let the others decide what comes out of it. You still have a responsibility, especially in the discussion about dual use. And the innovators as well, and the startups, they're kind of, okay, waiting until you've got a product, like, I don't know, like it doesn't ring well in my ears, especially with this. So for them to say it and then understand that, oh, okay, maybe it's that sounds wrong, it's really helpful. Mm-hmm. And to see also those next generations of scientists and engineers coming over and saying, we want to be part of that discussion is also very insightful for us. So you're asking what you can do to help. Again, I think dual use is interdisciplinary. So again, I'm really, really vouching here is like more humanities, more social science, first national quantum strategy, all to answer zero to humanities. I want to see this change, and you can see it in other jurisdictions across the world that they are involving humanities and social science first, and I think this is needed in Canada as well.
Absolutely.
Thank you.
And so with that, I'm just noticing now I have just over 3 minutes left for this panel. So what I'd like to do is go back to our panelists and in 30-second each, is there a final word that you'd like to, or a final thought that you'd like to leave with our audience? Starting with Nipin.
What is my final word?
Yeah.
Boy, it's hard to kind of encapsulate. I guess what I would say is, because this panel is about about dual-use technologies is that, as Christian said, many of these sort of platform technologies being developed are inherently dual-use. It's just that we now have a great opportunity to treat them in a way where we can kind of bring resources to bear and priorities as a country to bear to realize the full potential of these technologies. I think the input of people who've thought about these issues, the input of those who are aware of effective models of doing so, I think will be very helpful. So I think the dialogue is kind of open with defense and with ourselves to figure out how, given the opportunity and given the imperative, that we can kind of make this work really effectively, given the Canadian context. So I think I would just say that I hope there's more conversation with government and with other knowledgeable people about how to realize the potential in quantum, but also in other areas.
Absolutely. Alex.
Yeah, thank you. So I'm going to go really fast because I encountered this idea yesterday. I don't know who to talk to about it, but people in the room here know something about policy, so I'm just going to go ahead here. I was at a conference in Kingston. It was a military academic conference in the maritime space, but we had people from the Air Force there, we had people from the Army there, and the commandant of a local college took me on a tour of his facilities and told me a little bit about what they do and asked me if I know about the reserves. And so the Army Reserves and Navy Reserves is kind of like a part-time job that people can take on, minimum one day a month involvement, and they contribute to our military in this way. But as an employer, I stood there and I thought, if I have two resumes on the table and one person has a part-time engagement and one doesn't, otherwise they're equally the same, I would hire the one that doesn't have the additional engagement. And so it sounds like we could actually help add to the reserves and maybe, remove some barriers there by helping employers with incentives to hire people from the reserves. It would incentivize employees to come in and say, hey, you get a benefit if you hire me. And it will incentivize people to go to the reserves because they have this extra employability, advantage. It's just an idea that I had. I don't know who to bring it up with, but there it is. And I guess the conclusion from where I'm sitting is that I'm really excited about this coming year, given what's going on in defense and how our government has been reacting and kind of pushing for quantum, pushing for tech. There's so much coming up.
I love that, thinking outside the box. Well done. I have 0 minutes left, and so I'm going to leave you with that, Christian. Very sorry, very bad at moderating. I'm going to take an extra 1 minute or so of our time.
I just hope that we conveyed how excellent quantum Canada is in quantum, and that this is a new industry getting created, and we should be all proud of it. We're playing to win. We're not a small player. We can play internationally, and we're there to win. So hopefully you're getting from that panel and get an understanding that for this time, at least, every Canadian should be very proud of that quantum ecosystem, and that this time is the right one, that we're not repeating the same mistake, and we're going to actually transfer that scientific excellence into tech transfer, into actually creating jobs and helping the economy. So, yeah.
Thank you very much. So thank you very much, Nipin, Alex, Christian, for a very interesting and compelling discussion on quantum science and technology. Thank you to all of the audience for staying with us and your questions. To the organizers of the conference and those who helped me organize this panel, thank you very, very much for all your support. Folks, think Team Canada. Team Quantum Canada. We have an opportunity to seize. We've got all the ingredients. Let's keep the dialogue going. There's more events coming up. Our usual Quantum Days coming up in February and others. So lots of other opportunities to chat. So thank you very much.